Good morning, students. I'm here again as your physics teacher. Remember, Mrs. Blessing Imo, your physics teacher. From our previous class, we stopped at causes of motion, and I asked you to go and consult our new school physics. I'm sure many of you have done that. Okay, so today is week 3. We are going to look at some equations of motions. Now, we have many equations of motion, but today we are going to treat like 3. And it is going to show here, and you will see what I'm talking about. Now, the first equation, consider a particle with initial velocity, that is capital letter U, and it attained a final velocity v in a time t. Now, for the uniform acceleration, we have a equals to increase in velocity all over time. What do I mean by that? In the symbol pattern, we have a equals to capital letter V minus u all over t. Now, from there we have the final equation, that is equation 1, v equals to u plus at. And v stands for final velocity, while u stands for initial, and a stands for acceleration, while t stands for time. Now, let us look at equation 2, which we are going to look at distance. Distance equals to average velocity times time. Now, this is given as capital letter S equals to, you open a bracket, u plus v, then you close the bracket, t, small letter t, all over 2, such that we have the final equation, which we call it equation 2, as ut plus 1 all over 2 at squared. We call that equation 2. Now, S stands for distance, U stands for initial velocity, V stands for final velocity, T, time, and A is acceleration. Now, this will make it very easy for you to know how to solve some problems, some challenges in physics, when once you are able to know the parameters. And what do I mean by the parameters? The S, U, V, T, and A, and you know what it stands for. Now, the next one on our scheme we are going to look at, still under week 3, is what I call vertical motion under gravity. And somebody will ask, what do you mean by gravity or vertical motion under gravity? You know we have vertical and horizontal. Now, if air resistance is neglected, all bodies moving under gravity have the same constant acceleration. Now, this acceleration is called gravity. Now, example, you standing in an upstairs and releasing a football down. That is what I mean by vertical motion under gravity. Okay, quickly, let's look at some graphical presentations of this motion. Okay, today I'm just going to show you only 2 graphical representations of motion. The first representation is distance time graph. Distance time graph, where we have the line coming from vertical, horizontal, and you cross, and it's going to display. Then we have the distance and the time. Then the second one is what we call displacement time graph. And for you to see exactly what I'm talking about, you remember in our previous class I asked you to consult our new school physics by M.W. Ayankoha. So also do well to visit us at St. Paul Comprehensive Secondary School, Imek Road, Ikotepene, Akwa Ibom State. Bye bye. See you next week.